Let's start this discussion by talking about what exactly a polygon is. A polygon is a virtual or digital surface that's made up of three different components. Those components are the vertex or vertices, which are the points. You can think about these as sort of like control points or anchor points in an app like Illustrator or Photoshop. The second component is the edge, which connects those points or vertices. And the third component is the face, which makes up the area in between the edges and vertices. Now, the one we're looking at here is known as a tri or triangle. And this is the simplest form of a polygon. And the reason that this is the simplest form of a polygon is that no matter how we sort of manipulate the edges or the vertices, the polygon will always be planar or flat. So at the end of the day, a triangle is the simplest form of a polygon. And at its base, every polygon is made up of triangles. The next form of polygon we're going to look at is called a quad or a square. This polygon has four sides, four vertices, and one face. Now, at the end of the day, like I said, all your polygons are going to be converted down to triangles. So if I were to take this square or quad and manipulate the geometry a little bit, if we look at the geometry at certain angles now, we can see that this one quad or one square polygon is basically two triangles. And we could illustrate that even more by drawing an edge right down the center. So every quad is basically two triangles. Now I can manipulate the flow of this triangle by changing how that edge is drawn in between them. Now, even though all quads are triangles or two triangles, we tend to work in quads more than triangles because they're a bit easier to manage. So let's look at this example here. So I have this polygon plane that's made up of a bunch of quads. And if I want to manipulate this, or if I want to add geometry to this, like an edge loop, so I'll go to my multi-cut tool and add in a edge loop here. You can see that it's really easy to add in edge loops because everything is quads, and our edge loops can flow along that quad polygon sort of topology flow. However, if we have a mesh made up of triangles, we cannot draw edge loops in between. So I'm holding down control here, the same as I was here to create edge loops. But you can see my edge loops just are not being created because we have a mesh made up of triangles. If I were to go in and delete some of these triangles like this, I could then add a edge loop here, but you can see that that edge loop will stop where there's a triangle. So even though all quads are essentially two triangles, we prefer to work in quads as we're modeling because they're a bit easier to manage and control, and visually our brains can make a little bit more sense of how the topology flows if it's all sort of in a grid pattern. So if it's all sort of quads, our brains tend to be able to accept that a little bit easier rather than looking at a mesh that's made up of a bunch of triangles. The third type of polygon we're going to look at is what's known as a ingon. In just meaning any number. So an ingon is a polygon with any number of sides more than 4. So as we see in this example here. Now, ingons can be a bit of a hefty subject. There is some debate in the community about whether or not ingons should all be gotten rid of in a 3D model, or if some of them are allowed to stay. And whether or not you follow one side or the other, there's one thing that makes ingons really difficult to work with, and that is that a lot of our tools will not work if we have ingons in our model. So a lot of the things that we need to do, things that we need to do to these models, will not work if there are ingons in the model. So as a 3D modeler, ingons is something you're constantly battling. You're constantly trying to get rid of in your 3D model. And it's because it will kind of keep you from performing a lot of functions on your model that you need to perform. Another reason ingons are bad is because in a lot of cases, they don't show up at all in a game engine or a real-time engine of some sort. They'll just show up as a hole in your model. And the reason that is because there's many different ways you can compute an ingon. So, for example, if we were to go back and look at a quad, and if we were to think of the two different ways this quad could be translated into triangles, right? It's only really two different ways. It can either be translated in this direction or in this direction. So there's only really two different options of how that one quad can be converted into triangles. With an ingon, it's exponentially more. With every edge that you add in an exponential amount of different variations of how that one polygon can be converted into triangles. So, and as we move these points around on our ingon, we can see that the sort of overall shape of that object will change dramatically, right? So I do something like that. And if I were to take this object now and triangulate it, so we'll go to mesh, triangulate. Actually, let me duplicate it first so we can see the difference here. Mesh triangulate. We see one version of how that was triangulated, right? Now, let's say we duplicate this again and we manipulate it even more. And we'll go to, once again, mesh, triangulate. And we can see that that is being manipulated or converted into triangles in a totally separate way. So whether or not you believe ingons are bad or they can be useful in certain situations, one thing is for sure, and then that is as you're modeling, you should try to get rid of as many of them as possible because they can cause a lot of issues for you later. As a 3D modeler, battling ingons is something that you're always going to be doing. They will happen. Even the best 3D modelers will create ingons. It's just the nature of how you model. So I wouldn't really try to model without using ingons. You can use them to model, but at the end of the day, you should try to remove them from your model. So next we'll talk about how to locate your ingons and how to possibly fix them if you need to. Now, the first way to locate ingons is obviously just looking at your model visually with your eyes, and you'll learn to kind of spot them when they're apparent to you. For example, this one here is clearly an ingon. I can look at this face and I can count that it has more than 4 sides. This one has 5 sides to it. Now, the other way to locate your ingons is to use the mesh cleanup function. So the way that I like to use the mesh cleanup function is I'll select my object in object mode, and then I'm going to go up to mesh cleanup, and I'm going to look at the settings for mesh cleanup. Now, by default, your settings are going to look like this. So you're just going to have cleanup matching polygons, apply to selected objects, and keep construction history. I prefer not to let Maya clean up my polygons for me because it will often do things that I don't necessarily want to do. I would rather choose how I want to clean up my polygons than let Maya choose how to clean them up. A lot of times it will delete faces, it will triangulate your mesh, or sometimes completely disconnect parts of your mesh to attempt to fix your troubled polygons. But in this case, I don't like Maya to choose how to clean up my geometry. I want to clean it up myself. So instead of clean up matching polygons, I'm going to choose select matching polygons. I'm going to choose four-sided faces. So this is your ingons. Anything with more than 4 sides is your ingons. So we want to choose faces with more than 4 sides. I'm also going to select lamina and non-manifold geometry, and we'll talk about those a little bit later. And then I'm going to hit cleanup. And what that's going to do is select my ingons. Now, we know this one is an ingon because we can clearly see that that face has more than 4 sides. But why are these guys ingons? So let's kind of look at that and talk about that a little bit. So this is an ingon, even though that looks square, even though that looks like it only has 4 sides. If we were to count the edges around that face, so for example, we'll go into our edge mode and count the edges around the face. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 faces around, or 12 edges around this one face. So even though this one face looks like a square, it looks like a quad, appears to only have 4 sides, it in fact has more than 4 sides. Now, the easy way to fix this one in particular would be to just grab my multi-cut tool, and I can just redraw the edges to kind of make that a quad again. And now that is quads again. Now, if I were to undo this, depending on what we're doing with our model, we could do this a little bit differently. I could draw my edges sort of like in different directions, making them triangles. And doing something like this. Now that is once again all quads and triangles, even though we did it a slightly different way. Now let's look at these 3 faces down here. Why did it choose those as ingons? So these clearly, visually, look like they have 4 sides, right? And they look like quads. But then let's take a look at the vertices for these faces or these polygons here. So let's right click and go to vertex mode. And then we see that we have these little vertices here. And even though our edges or our polygons look like it has 4 sides, in fact, this one has 1, 2, 3, 4, 5, 6 sides, and this one has 5 sides. So oftentimes the easiest way to get rid of these polygons are just to select those little floating vertices right there and delete them. Now the reason this works, and oftentimes we can just select our entire model and hit delete, and that will get rid of any floating vertices on our model. Now the reason this works is when you select a vertice and hit your delete key, it's only going to delete vertices that are connected to 2 edges or fewer, right? So this one edge or this one vertex here is connected to 2 edges. This vertex is connected to 4 edges. So it's not going to delete this vertex. It's only going to delete this one when I hit the delete key. Now, as your model gets more complex, you'll learn you'll get a little bit better about finding ingons. In many cases, fixing an ingon is just a matter of taking your multi-cut tool and sort of changing it into a triangle like that. Or we can select this edge here and just control delete this edge completely. Now, I want to talk briefly about the difference between deleting and control deleting or command deleting. When you delete an edge, but just by hitting the delete key, your vertex stays there. So even though we got rid of that edge, these two faces now are still ingons. So if we instead control delete or command delete that edge, it will also delete the vertex. Now, finally, let's talk about what's called non-manifold geometry. Now, if you remember, we went up to mesh cleanup settings, and we checked these two settings, lamina faces, faces sharing all edges. So this is basically when you have two faces that are sort of sandwiched together. And this is known as non-manifold geometry. But then you have this word non-manifold geometry. Now, there's all sorts of different types of non-manifold geometry. But at the end of the day, this is just sort of geometry that should not exist in your model. It's bad geometry. It's some geometry or polygons that's going to cause errors. So we really want to get rid of all of our non-manifold geometry. This may not just be faces. This could be vertexes and edges as well. And we want to get rid of these. So it's a good idea to also have these selected in your cleanup options. When you hit cleanup, you can see that we fixed them all here. So we no longer have non-manifold geometry. Now, one form of non-manifold geometry is called a T-face. So if I go to edge mode and grab an edge and I extrude an edge out here, we'll talk about why it's black in a second, but this is considered to be non-manifold geometry because this is a face, right? That or an edge that's connected to three faces, and most edges should only be connected to two faces, right? Should have one in between them. So this is known as a T-face, and this is non-manifold geometry. Now, a lamina face would be if I took this face and merged these vertices together here with something like my target weld tool. That will cause a lamina face. Now, in some cases, Maya is pretty good at recognizing that that shouldn't be a geometry that you have, and it will oftentimes just get rid of it for you. So if I delete this face, you'll see that it actually has a face behind it. So this is, in fact, a lamina face now. As I said, sometimes Maya will solve that issue for you, just depending on what actions took you there. But now if I do a mesh cleanup again, it will select that face and the vertices around it because that's a problematic non-manifold piece of geometry. If I delete that face and then I do a check again, maybe we need to delete it one more time, make sure that it's deleted, and let's do one more check, and we're all clear. Now, if you do a cleanup and you get these green little vertices, that's because of errors with your UVs, which we haven't discussed yet. So you can kind of just ignore those for now if they're green. If they're yellow, that means you have issues with your vertices or a particular vertex. Now, there's one more thing we need to talk about when it comes to polygons, and that is something called normals. This is a term that basically represents the way that a light or a source of light will bounce off of this virtual surface, which are your polygons or your faces. Now, every polygon has a normal, and it actually only has one normal, meaning it only has one direction. So if I were to take this sphere and I were to delete half of it or a portion of half of it, by hitting the delete key, and we look inside of that sphere, we see that it is black. And no matter how we sort of rotate around, we don't really get any light going inside of that sphere. That's because every polygon only has one direction. And if you see that it's black, you're actually looking at the wrong side of the polygon. If this were in a video game, this would just be invisible. So we would see the polygons from this side, but we would not see it from this side. Now you can kind of ignore this fact by coming up to your lighting in your viewport and turning on two-sided lighting. And now we see both sides of that polygon. But I think when you're first learning how to model, it's a good idea to have that turned off so you can get a sense of the direction of your polygons. Another example, let me just undo that here a little bit. And let's say we take a face on the sphere and let me do one that's kind of straight on here, straight on an axis. Like this guy. And I'm just going to extrude all the way back, right? So we're extruding through that sphere and we're looking at it from the back. And this is black because we're actually looking at the inside of those polygons that we've extruded. So they are facing the wrong direction. Now, every polygon has a single direction and it has a normal. We can see the direction of these normals if we go to our mesh display menu, and with our object selected, I'm going to choose Harden Edge. And now we kind of see the sphere for what it is. We can see all those flat faces, those faceted, almost looks like a gemstone because it's got all those facets, and we see all of our individual flat faces for all of our polygons. This is because the normals for those polygons have been flattened out. Now, if I were to select the sphere now and go to Mesh Display Soften Edge, it's going to average out the normals and give my model a smooth appearance. Now, this does not actually change the topology of the model. We still have the same number of polygons. The polygons are still shaped the same, but it makes my model appear to be much smoother. Now, a few things that you can do here. For example, if I want to take this sphere and we'll duplicate it, and then I'm just going to go to, say, a side view, and I'm going to go to my face mode, and I'm going to delete half of this sphere. And then we'll just jump back to my perspective view. Say I want to be able to see the inside of this half sphere or hemisphere, but I don't care about this. I want it to be more of a bowl rather than a dome. So I want to be able to see those polygons on the inside. We can select our object and we can go to Mesh Display Reverse. And that will switch from polygons facing outward to facing inward. Now we can edit our model, our normals on an individual level. So if I wanted to just reverse the normal of one face, I can just select one face and go to Mesh Display Reverse. And you can see that even though that looks black, if I were to look at this from the inside, we can see that we get our shaded view on that. If you happen to have a model that you're working on and say that you have a bunch of polygons that are kind of facing in the wrong direction. So for example, say you have something like that, you can really easily just get everything faced in the correct direction by going to Mesh Display and Conform. And that will try to conform everything to the correct orientation. Now you'll notice now that these polygons that we reversed, they have like this hard edge around them. We can then go and fix that by going to Mesh Display, Soften Edge again. We can also edit our geometry or manipulate what edges we want to look hard or sharp and what edges we want to look soft. For example, say I want to take this center edge loop and scale it in. So we get sort of like, I guess this would be like a Death Star shape. And say I want to make it look like these edges have a hard corner on them. I can then individually select the edges that I want to look hard and go to Mesh Display, Harden Edge. And now we get a completely different look on our 3D model without actually changing the surface or changing the polygons of the model. If I want the outer edges to look sharp or hard, but not the center edge here, I can select that center edge and then once again go to Mesh Display, Soften Edge. And now I have something that looks like it's sort of beveled in a little bit and not a sharp surface there. So manipulating and editing your normals is a very common way to change the look of your model, especially if you're modeling something that's considered to be low poly or having a low amount of polygons. You can manipulate your normals along certain edges to make them look like they have more detail than they do without actually having an image texture or image map on your model. Now, the last thing I want to point out here is that you'll see this little sort of heads up display that I have. I prefer to keep this up because this sort of tells me how many polygons I have in my scene and how many polygons I have on a single object. So this first number here, and we're typically only looking at tries, right? Because again, every polygon is converted down to triangles at some point in its life. So this sphere has 760 tries, and the entire scene also has 760 tries. Now, if I were to just duplicate the sphere, we can see here this left value is now 1520. And if I click on a sphere, this says 760. So the middle value here is the poly count or triangle count for the object you have selected. And then the left value is the triangle count for all of the objects in your scene. So I do think it's very important to understand the nature of polygons before you begin your 3D modeling journey. I think once you understand these fundamental concepts, it's you're going to have an easier time manipulating geometry and fixing non-manifold geometry when it gets created. And it is going to get created. It's something that happens naturally as you're 3D modeling. Ingons will also happen naturally. You just sort of have to learn how to get rid of them and how to edit them and clean up your geometry, optimize your geometry as you're going. And that's something you will learn naturally as you learn to 3D model.